All right, hello. In this video, we're going to be talking about Lewis structures or dot diagrams, that piece of the review quiz or practice test that you didn't know how to do. So I'm going to just start off by throwing aluminum up here. Now, this is one correct answer for aluminum, but there are a couple of others that would work as well. Or all four of these are correct for aluminum. Now, you might notice the thing they have in common, they all obviously have Al because, aluminum. But there's also 3 dots on each. Well, where are the 3 dots coming from? Why 3 dots? Why 3? Well, that's because aluminum has to have 3 valence electrons. How do we know that? Well, we know that because aluminum is in group 13. So we talked about this trick earlier when we did, I think, most common ion and most common isotope. We talked about this trick. If you need to figure out how many valence electrons an atom has, you can look at its group number. Now, I did tell you this only works in the S block, which is the first 2 columns, or the P block, which is the last 6. Does not work in the D block, which is the 10 in the middle, or the F block, which are the 2 rows at the bottom. For the S block, it's just the number, the group number, so 1 or 2. So everything in this column has 1 valence electron. Everything in this column has 2. In the P block, it's a little more work because the P block, these all have a 2-digit number, but you still just drop the 1. So here it's 13, so we drop the 1, there's 3. 14, we drop the 1, there's 4. 5, 6, 7, or 8 valence electrons. So since aluminum is in group 13, it has to have 3 valence electrons. Okay, and that's why it has to have 3 dots. Okay, so now we're going to start first off by finding helium. That's this box right here. Put an X through this box. We are not going to do any Lewis structures for helium because helium does not follow the rules. This time it's helium. Hydrogen actually does for a change this time, but helium does not. So we're not going to mess with helium with Lewis structures. Might be a good bonus question, but we're not going to touch it otherwise. So we're going to start with lithium over here. How many dots should lithium get? Well, it's in group 1, so it should have 1 dot. Now, the question becomes, though, where does the dot go? So I'm going to draw this a little bigger here. So if you imagine a box around lithium, there are 4 sides to that box. And the maximum possible number of valence electrons is 8. You know that because we taught you that last week, or in a couple of videos ago. Okay, the maximum possible number of valence electrons is 8. So, therefore, at the maximum amount, there will be 2 dots on each side of this. Okay, the first dot, though, can go on any side, but it has to be in the middle. So you can put it on the bottom, you can put it on the top, left, right, I don't care. It don't matter. You can put that dot anywhere you want to. So I'm going to put it on the bottom over here. By the way, you should be filling out this worksheet as you go. So if you haven't done that, you might want to pause this, go back and print this off or grab it, pull it out, whatever. So I'm putting 1 dot on the bottom on lithium. Now, the next one we're going to do is beryllium. Now, beryllium is in group 2, so that means it's going to get 2 valence electrons instead of 1. So here's where your first restriction comes up. You are not allowed to pair dots until you absolutely have to. That is because electrons repel each other. They do not want to be together unless they have to be. They're going to avoid it for as long as possible. That means that if the first dot goes on the top, the second dot cannot go on the top. It can go on any other side, but it cannot go up here. So I'm going to go right there. So then our dot diagram would be one on the top, one on the side. But again, it can be any two sides. It doesn't have to be specifically the top or the left or the right or where at the bottom, wherever. You can put it wherever you want. Now, aluminum, we've already talked about, so I'm going to put one on the top, one on the bottom, and one over on the left here. And we're going to skip lead and jump to nitrogen. I want to talk about nitrogen because nitrogen is a little weird. It's not weird, really. It's just different from what we've done so far. Nitrogen is in group 5. So that means that it has to have 5 valence electrons, which means its dot diagram, or Lewis structure, has to have 5 dots. So the first 4 dots all have to go on different sides. So it has to have 1 dot on every side of its box. Okay, it has to have 1 dot on each of its 4 possible sides. But then it has to start pairing them up because they can't go anywhere else. Now, again, there are some restrictions, some places you are not allowed to put dots. So I'm going to use red for the places where you can't put dots when you have to start pairing them. You cannot put dots on the corners. Okay, you also cannot put dots extended away like this. So that's off to the side, on the sides, or above or below down here. Okay, the dots have to be touching this imaginary box. So we can put our 4th dot, or our 5th dot rather, here, but we can't put it there. So, and again, the pair can be on any side. It doesn't have to be specifically this side. It could be on the bottom, could be on the top, or it could be over here. So I'm going to go with that. So 2 here, 1 up here, 1 down here, and 1 there. Now, that leaves 4 more that I have filled in here. Lead, polonium, iodine, and krypton. I know that K is kind of hard to read. I want you to pause this video and do the dot diagrams for lead, polonium, iodine, and krypton. So, yeah, do that. Pause. All right, I'm assuming you're done now, and I'm going to do these. Okay, so lead has to have 4 because it's in group 4, so it has to have 1 on each side. So 1 on top, 1 on bottom, 1 on the left, and 1 on the right. Okay, polonium is in group 6, so it's going to have 1 on each side. And then it has to start pairing up, so it's going to have 2 pairs. So again, it doesn't matter which sets you are pairing, so long as you are not doing any of these things. Iodine's going to have 3 pairs and 1 by itself, so I'm going to put 1 pair on top, 1 pair on bottom, 1 pair on the right, and then solo on the left. And krypton, having 8 valence electrons, is going to have 4 pairs, 1 on each side. So kind of like lead, except all pairs. There you go. So those are these. Those are your practice. Excuse me, your practice ones. Now your assignment for this, to make sure that you're actually getting it and to help make sure you remember it, is to fill in the rest of these. And stop, because I can already see a couple of you going down the column. Don't do that. Don't go down the columns. You need to make yourself go across the rows. Okay, make yourself change. Switching tasks is how you remember things. So start with hydrogen, then do boron, then carbon, and skip nitrogen for oxygen, then fluorine, then neon, and then come back over for sodium. Don't go hydrogen, sodium, potassium, rubidium, cesium, and francium. Don't shoot down the columns. Go across the rows. The key should be linked in Canvas if this video is up. And that's pretty much it for this. So I'm going to sign off here. Have a wonderful day, night, evening, afternoon, morning, whatever. And I will see y'all next time.